Hi everyone, welcome back. This video is about one question: what is LangGraph Studio and why LangGraph Studio? AI agents are becoming increasingly popular, and according to this Gartner report, they are going to reach peak popularity in the next 5 or 10 years. So if you are in the market looking for tools to build AI agents for your own business use case, then LangGraph and LangGraph Studio is going to help you build exactly that very easily. This video will have a significant amount of technical elements to it. So if you're someone who often shy away from code, especially Python code, then this video is not for you. But for the rest of us, if you're familiar with any sort of development like Android or iOS development, then you know that developers are given something called an SDK or a software development kit and an IDE, the integrated development environment. For LangGraph, the SDK is LangGraph Python framework or their JavaScript equivalent, and LangGraph Studio along with other code editors like VS Code or PyCharm is supposed to be the IDE solution for building the agentic applications. But before we go any further, why LangGraph and not Crew AI? Well, both LangGraph and Crew AI are frameworks to build agentic applications, but Crew AI is more of a high-level framework. While that means Crew AI is easier for developers to understand, but LangGraph, being a more low-level framework, allows you to wrap the business use case more closely by implementing more customizations in your workflow, which is required in real-world business use cases. Setting up LangGraph Studio only supports macOS at the time of recording this video. Additionally, it requires that Docker engine is running in your MacBook, so make sure to install Docker Desktop. I'm sure it will also work with Docker CLI if you don't want to install the full-fledged Docker Desktop application, but I find the Docker Desktop to be useful in managing the containers on my machine, so I'm going to use Docker Desktop. To set up LangGraph Studio, simply navigate to their website where you can download the latest version of the LangGraph Studio. If you want to use earlier version of LangGraph Studio, then I would urge you to go to this website. I'll leave a link to this GitHub page under the video. You can see that this is in beta still, but they maintain a very frequent update schedule. If you are wondering, I'm going to use this specific version. The reason is that I can see that when I write multi-agent code, I am not able to see the steps within that node. So I'm going to explain what that means when I reach there. But for your reference, I'm going to use this specific version and not the latest version. And this specific version has been liked, and that is not true even for the older versions. So it seems that other developers are also kind of acknowledging the fact that this is more of a stable version. So you can go ahead and click on this link and download the DMG and simply install. And after you open this up, it is probably going to ask for a Langsmith account, and you don't have to create an account. You just simply log in using your GitHub or Google and you'll be all set. Before launching LangGraph Studio, make sure that you have Docker running on your machine. If not, you'll get an error like this. After you open LangGraph Studio, you'll get a screen like this. They have few different templates to start from. In the GitHub repository, they also provide an example project where they have built an online search agent using Tably Search. To build a step-by-step understanding of LangGraph Studio, however, I'm going to start with an absolute bare bones project and add elements to it when we need it. I have created a basic LangGraph project that has the bare bones files that are required for LangGraph Studio to recognize the directory as a LangGraph Python project. I'll take a git clone of that project. I'll open that up in LangGraph Studio. You can see that it starts up a Docker image for that. Pressing and holding this icon at the bottom right corner can allow you to change the code editor of choice. I'll choose cursor here. We can see that the workflow has no node at the moment other than the start node. In the project directory, the file langgraph.json contains the configuration details. It mentions the dependency as a requirements.txt file in the root of the project. In the requirements, we have only LangGraph Python package as the only dependency for now. The configuration also defines something called a graph. A graph is simply a workflow that the agent has to follow, and it defines the graph in the agent.py file. Inside the agent.py file, we can see that we have defined the simplest of workflow. First of all, at the last line, you can see that I have defined a graph, and this is mentioned in the langgraph.json file as we just saw. Now each graph in the langgraph has a state. The state is usually defined as a dictionary. A state is what maintains the state of the workflow at any given point. When the workflow is in full swing, different nodes of the graph will receive the state and return a modified state. This modified state is the only way different nodes can communicate with each other in the LangGraph architecture. State is not only a way for the nodes to communicate with other nodes, it's also a way for a node to communicate with the LangGraph engine itself. By that, I mean that whenever a node execution completes and a modified state is returned, the LangGraph engine has to determine which node to call next. If there is a direct edge specified from one node to the other node, then LangGraph simply calls that next node. But oftentimes the call will be conditional, and LangGraph engine will pass the modified state to a condition check, which will unpack the state to determine which node to call next. And this condition function's return value will tell LangGraph engine which node to call next. To summarize, a LangGraph workflow has a state, one or more nodes, and one or more edges. Edges can be direct edges or conditional edges. We will build everything in a step-by-step manner so that we can have a thorough understanding of each. So here in this line, we have defined the state as a type dictionary which has a key called messages. You can add more such attributes, but for our case, the messages will suffice. This attribute is defined as a sequence of base message objects, as you can see. And there are a few different more specific types of messages in LangGraph, namely human message, AI message, etc., similar to any multi-turn chat message types. Each node will receive this state and add to this messages attribute, making it longer and longer over time, which will maintain the state of the workflow at any given point. This attribute will be unpacked in each node to generate further responses, or as we said, in each conditional edges to determine further node calls. In the code, let's go ahead and add a node. As I said, a node is just a function that takes a state and returns a state. I'm calling this function func1 for now. I'll add this node to the graph or workflow. If I save, you can see that it says node not reachable. So we get compilation errors as well in the LangGraph since we are compiling it explicitly, which adds some sort of safeguard to our code. So I'll add an edge from start node to the func1 node. We can see the function is added as a node. We can even go ahead and test it. If I write here, how are you? You can see that we get an output from the function 1. If we hover over this on the right, you can see the nodes are highlighted on the graph. I'll click the eye icon here to view the output. At this point, I can see that it has something called messages and human message saying, how are you? If I see the JSON, I can see that it is nothing but the messages sequence that was defined within the state that has a message object of type human. This is being displayed by the LangGraph Studio like this. And you can click on this JSON button as well. And that way you'll be able to see the raw JSON. I can see the JSON is exactly same in the func1 node output as well, because the func1 node returned the state as it received without modifying it. So I'll go inside the func1 function and return a base message object, and just for fun set the type as cat. I'll save it and automatically it reloads the changes. Now I can send the same message here, or I can hover over the start node here and click rerun. That way it will just rerun with the same input as earlier. You can see this time the output state from the start node is same, but func1 node has added a message of type cat to the messages dictionary. We can see that in the JSON as well. Now, if we become serious, then we will return an AI message. I'll import it up here. I'll save it and rerun the start node. We get the same output, but if we peek into the JSON of the AI message, we can see that it has few different additional parameters now. One of them is tool call, which is empty, meaning that when we use an LLM to generate these responses, and note that we are writing the response, I am fine in the code here. But if we were to initialize an LLM right here, and if we were to bind a few tools with the LLM and ask a question that would require the LLM to query the tool, then we can tell that this attribute tool calls will not be empty, rather will contain few information for the tool calls. Also, since tool calls is an array, we can also tell that it is possible for the LLM to generate multiple tool calls at the same time. Now let's do that. First of all, I'm not quite liking the name func1. I think it's enough already to make the point that a node is nothing but just a function. I'll change the name to node1 in all instances of the code. I'll use OpenAI models here since they are good for tool calling, but you are free to use any other model of your choice. I'll go to the LangChain documentation for using OpenAI. We will have to install this Python package in LangGraph. It is as simple as mentioning the Python package name in the requirements.txt file and saving the file. That will make sure that LangGraph Studio installs the package and reloads the project. I'll use the given code to create an instance of the LLM, although I'm going to use GPT-4o mini as that works just fine. You'll have to get an OpenAI API key, however. Simply go to platform.openai.com/API keys and log in if you haven't already and get your API key. Now, to save environment variables in LangGraph project, create a .env file in the root of the project and mention this in the langgraph.json file like this. After you make changes to the config file and save it, for some reason the project closes, just simply reopen the project from the recent projects. Inside the .env file, paste your OpenAI API key with the name OpenAI API key. Save it, and this name will be used by default by the chat OpenAI constructor function here. Now inside the node 1, rather than sending a message ourselves, we are going to use the LLM to generate the response. First, we'll unpack the messages array that contains the historical messages within the state. Then say llm.invoke and pass the sequence of historical messages here. It's that simple. Now if we test, we can see the familiar response. I'm just a computer and so on. Now if we ask how is the weather in LA, it says it doesn't have real-time information and things like that. But let's add a dummy tool for now, and you might have guessed a tool is also just a function. So I'll just write a simple Python function called getWeather. It just returns that the weather is sunny in whatever location is mentioned. To make it a tool, however, we have to add some additional metadata to the function. There are a few different ways of defining a custom tool in LangGraph, and I'll leave a link under the video. The ways are simply different ways of declaring what the function does and what each parameter means, so that when we bind this to the LLM knows how to generate the tool call message. Now, one of the simplest as well as the versatile way of doing it is using the tool decorator. Now, it comes from the langchain.tools, so we need to install the langchain base package. I'll add langchain in the requirements.txt file. I'll save it and wait for the project to reload, and then import tool from langchain.tools like this, and add this decorator at the top of the function. You can see in the documentation that a docstring for the function is mandatory, which will be used as a description for the tool. We will add gets current weather for the given location. You can see that the tool decorator supports using custom name for the tool as well as passing an argument schema that provides additional description for each parameter like this. That is the reason I think this is simple as well as very versatile way of defining a custom tool. Now after the initiation of the LLM, I will use the bind tools function and pass that getWeather function as an array. Now you can tell that we can pass multiple functions like this in this array to provide multiple tools to the LLM. Now rather than using the LLM to invoke the response, I'll use this LLM with tools to generate the response. I'll save it and rerun this. We can see that it calls the getWeather function with location parameter set to Los Angeles. Now let's inspect the JSON. We can see that the tool calls is not empty and has a function call with name of the function as getWeather and argument location as Los Angeles. This tool call JSON is displayed by the LangGraph Studio in the visual format. Now please note that it doesn't call any tool just yet. This AI message that was just generated has a tool call parameter, which simply denotes the intent of the LLM to call a function called getWeather with the given parameters. Now LLM generates this message because that specific tool is bound to it, and it arrived at the conclusion that the human message can be responded to by getting additional information by leveraging the tool that it has access to. To actually execute the tool call intent, however, we'll have to create another node called ToolNode, and we want to conditionally traverse to that node only when the node 1's AI message contains any such tool calling intent. So to conceptually understand this, let's create another function called ToolNode. We will add this node as usual. Same as before, if we save, we get the compilation error that ToolNode is not reachable. Every node in the graph should be reachable. So we will say graph builder.add conditional edges from node 1 on condition 1. And same as before, condition is also a function that receives the state and spits out a string based on the state. And LangGraph engine checks the return string to determine the next node to call. We will say if it's something like path tool, then call ToolNode. If it is something like path end, then simply end the workflow. And we will have to import the special node end like we imported the start node. I'll define the function condition as something that takes the state and spits out a string. Here I'll unpack the last message within the state. Now if this message has tool calls property non-empty, then return path tools, else return path end. Now if we test how are you, we can see that the generic response, and since this time it does not have any tool call intent, it takes the path end and it ends the workflow. Now if I ask how is the weather in LA, we can see that this time there was a tool call intent and it took the path tools and traversed to tool node, and from there the engine didn't find any further nodes to call, hence ended the call workflow. But ideally a tool node will generate response like this. In this case, the weather is sunny, and then return back to the parent node. So I'll add a direct edge from tool node to node 1. Now if we rerun this, we can see that we get an error. It says that An assistant message with tool calls must be followed by tool messages responding to each tool call ID. The following tool call IDs did not have response messages, and then it lists the tool call ID. Actually, if we see the tool call intent generated by node 1, we can see that it has a tool call ID. To satisfy this intent, it expects that the next message object that gets pushed into the messages sequence has the type tool message and has the same ID that matches the tool call intent. That way the node 1 will know that the tool call intent is satisfied. So in the tool node, rather than generating an AI message, let's make it a tool message. We'll import it first, and a tool message has a mandatory parameter called tool call ID, and we will extract the tool call ID from the intent first. So if you see the JSON, I'll get the last message first, and then the last message will have a non-empty tool calls array from which I'll get the last object, or the first object, doesn't really matter in this case, and then get the ID. Now this is too much work to do ourselves, and I'm going to show you how we can do it using pre-built functions. But for conceptual understanding, let's extract the tool call ID and pass it in the tool message to fulfill the intent. Now if we run how is the weather in LA, we can see that we don't get the error, and we have now node 1 responding to the user query since it received the required information by querying the tool node. Now as we can see, the task of tool node will get increasingly complex as we add multiple tools to the node. That is to say, it has to first unpack the last message to get the function name to call, and then get the list of parameters to call the function with, and then actually call the function with correct parameters. And then after it receives the response from the function, it has to close the tool call with correct tool call ID. Also bear in mind that this AI message can contain multiple tool calls simultaneously. So all this work of a tool node can be easily implemented by a pre-built function called toolNode. We'll import it from LangGraph pre-built like this, get a toolNode function pointer using this, and it takes an array of functions as tools where we pass our getWeather function. And that's it. We can use this toolNode function pointer as our toolNode, and we can delete our own implementation of the toolNode function. I'll save it, and this time ask how is the weather in NY. We can see everything works out of the box. We can see that the response from the tool node has a tool message, which means the tool node function that we got from the pre-built function unpacked the tool call intent to call the getWeather function with correct parameters, which is location New York in this case, and on completion close the intent with the tool message and the correct tool call ID. Now we can go ahead and implement the getWeather function using any API of our choice. I'll use the OpenWeather just for demonstration. Since it's pretty straightforward implementation, I won't elaborate that much in this video. In the OpenWeather API, you can see that they give 60 requests per minute and 1 million requests per month in their free plan. Simply sign up using an email ID and get an API key. Save the API key in the .env file like before using the OpenWeather map API key. If you see the docs, the latitude and longitude properties are required in the API. So they suggest that you use the geocoding API here first to get the latitude and longitude from the location like this. But luckily for us, the LangChain community has an API wrapper implementation for just that. Here you can see that they require you to save the API key with the specific name, and that is why we saved the API key with this name. We will install the LangChain community package. Then I'll import the API wrapper from the LangChain community. I'll create an instance of the API wrapper called weather. It has another dependency called PYOWM. I guess it stands for Python Open Weather Maps. I see that it's mentioned in the docs as well. I'll add that too in the requirements.txt file and save. Now inside the getWeather function, I will write weather data is equal to weather.run and pass the location into it and return the weather data from this tool. Now if we ask how is the weather in NY, we can see that the tool node has provided a lot of real-time data and the node 1 has generated a rich response based off of that. Now let's switch gears and build a multi-agent workflow. So now in this video, we'll build a multi-agent workflow. Here two agents will have some specific tasks and relevant tools to accomplish those tasks. They will communicate between themselves to provide the required output. I'm going to create a researcher and a chart generator agent where the workflow will start with a research topic from the user, and the researcher will be tasked to do online research on the topic to the satisfaction of the chart generator, which will use the final research output and generate visual charts like pie charts, bar charts, etc. to demonstrate the research insights. And I'm going to constrain myself within the online research itself, but this can be online plus RAG knowledge base research as well. Now, since we are going higher level, we'll benefit from using some sort of pre-built functions. I'll delete everything that we have created and import the create react agent pre-built function. This function takes the LLM and the tools and gives us a graph workflow. I'll add a system prompt to the agent using the state modifier property. Also, we don't need any get weather tool here. I'll use some sort of online search tool. I'll use the DuckDuckGo search as it doesn't require any API key, but you can use the Tavily search tool as well. I'll add the DuckDuckGo search package as dependency. It also requires the LangChain community package. I'll save it and wait for the project to reload. I'll import the tool from LangChain community.tools. I'll pass an instance of the tool like this in the React agent constructor. I will ask to do a comparative analysis of Indian and Chinese economy. You can see that it generated multiple tool calls at once and then finally generated the output that also includes sort of chart type as we have mentioned in the system prompt. I'll call this workflow research agent. To create multiple agents, however, I will wrap this workflow within a node, and again a node is a function. I'll call this node research node. Now we'll define the state as before. Inside the node, we will invoke the research agent workflow with the state, and we are interested in the last message out of that workflow, and we will return that content as an AI message from the research node. And as before, I'll create the graph builder at the research node and make it reachable by adding an edge from the start to the research node, and finally compile the graph. Now let's add a chart node. I will add the function with the name chart node, returning something dummy for now, and I'll add the node here and add an edge from the research node to the chart node. I'll rerun the entire workflow with the same prompt. Now we can expand the research node to see the workflow there, and in the output as well, we can see the subgraph steps to see the steps research agent followed. Now one point here, if you cannot expand this research node or if you cannot see the subgraph steps, it might be that you are using the latest version of the LangGraph Studio. And as I mentioned earlier in this video, that the latest two versions, if you use, somehow I see that that feature is not working. If you use this version, then you'll be able to use this feature of expanding these nodes as well as seeing the subgraph. And here the final response from the agent is returned from the research node, which will be used by the chart node. Right now, the chart node is returning a static message. I have generated the chart, but let's change that. Just to emphasize the customizability, we can implement the chart node as a function, writing each step ourselves, or we can build it as a function wrapping an agent, which we will create using pre-built function called create react agent. I'm going to use the latter here. Same as before, I'll create a chart agent using create react agent function. Now I'll create a different LLM instance for this, and since it's a coding task, so you might want to use some LLM that is good at writing code, especially Python code. But in my case, I'm going to use the same GPT-4o mini and see how that works. And here I will use the state modifier to change the system prompt. I want to give it a Python shell where it can run the code generated to see if the code runs without any error. There are some API based Python REPLs. I think Brave provides such options for running the Python code and outputting the results. But in my case, I'll just use the LangChain's experimental utilities REPL. I'll add LangChain experimental package for this in the requirements.txt, and then I'll import the Python REPL from LangChain experimental.utilities. I will create an instance of the REPL and then create the Python REPL tool using the tool decorator on a function with the same name. Here for the parameter code, rather than simply defining it as a string, I'm also providing additional metadata information using the annotated. Then I mentioned the mandatory docstring, which describes the tool to be used by the chart agent. It says this tool runs the provided Python code and outputs if the code executed successfully or not. In case of error, the tool outputs details about the error. Here we use the instance of the Python REPL that we got from the LangChain utility. In case of error, we return the string representation of the error. Else we return executed and then any output that we received from the shell. Now, the reason I don't explicitly mention successfully executed in the else block is that often I find the shell does not throw any error, rather simply outputs the error. So we want to return that output even if the shell did not explicitly throw any error. Now we pass the Python REPL tool to the chart agent. That way this tool gets bound to this agent. In the chart node, same as before, we will invoke the chart agent with the received state and unpack the messages array from the chart agent's returned state, and then send back the last message of that as an AI message from the node. Alright, so now let's test this. I'll give it the same topic, do a comprehensive analysis of China and India's economy. Here within the research node, we can see that the subgraph steps here, but that is not of significance right now because we have already seen that this is the output we have received from the research node. As you can say that it has given the insights. Then finally, it is recommending the charts, that is a bar chart to compare the GDP and pie chart to illustrate the distribution of GDP, and then line chart, and that is received by the chart node. Although you can see that the chart node cannot find the matplotlib library. The reason is that the experimental REPL that we are using does not contain or does not come pre-installed with matplotlib. If you are using some sort of API based REPL, like as I mentioned from Brave and others, I think some of the common packages like matplotlib come pre-installed. Nevertheless, in our case, we have mentioned in the prompt that in case of missing libraries, ignore the error, as while actually running the code, we will have these libraries installed in the Python runtime. Moving on, we can see that it has outputted some Python code where it has generated some sort of charts to display the research findings. If we go inside the subgraph steps for the chart node, we can see that it has tried quite a few times. So first, it seems that it has generated this code block and then it ran it in the REPL tool. And in the first instance, when it didn't find the library, it updated the code somewhat and tried again. And then again got the same error, and then it tried it a third time and then finally concluded that it seems that this could not be executed because of missing libraries. I, however, can provide you with a code that you can run in local Python environment to generate the chart. Now, before I go ahead and run this in the Google Colab, let's do one update to our code. As you can see that we have only unidirectional flow here. So the research agent is giving the information to the chart node, but the chart node cannot ask questions back because we haven't created that path. So for that, we will first update the prompt of the chart node so that it knows that it can ask back questions to the researcher. So I'll add this line where it says that if the provided data is insufficient to generate the chart, ask for missing details, being specific about what you need. Do not ask for information that is already provided. You must ask for clarification or additional data at least once. This is just setting the minimum just to demonstrate how the backflow is going to work. However, this is not setting the maximum number of asks the chart node can make. We can argue the more number of times this bouncing off happens, that is the chart agent and the research agent bounce off of each other, the quality of output is going to increase in the process. I go on and mention in the prompt that when asking a question to the researcher, include the phrase question to the researcher, and this will be used in our logic to check if the message that has been generated by the chart node contains a question to the researcher. In that case, we will not end the workflow, rather we will divert the workflow towards the research node for further research. Now I'm going to add a conditional edge, and this will be from chart node, and I will call the condition chart to research condition, and if the return of this function is going to be research mode, then navigate to the research node. If the return of the function is path end, then just navigate to the end node, that is end the workflow. I will define this function chart to research condition, and inside this function, obviously it is going to take the state, it is going to unpack the state and get the chart node's message content, and then it is going to search in that content if it has the question to researcher key. In that case, it is going to just return the string research mode, otherwise it is going to return the string path end, and these two strings are being compared here by the LangGraph engine to direct the workflow either to the research node or the end node. So if I save, we can see the complete workflow here. So not only that we are getting a direct path from the research node to the chart node, we're also getting a conditional edge from the chart node back to the research node via the path called research mode, and this is going to prompt the researcher to do further research, and it is going to provide the information, and finally when the chart node has enough information, it is going to end the workflow. I would create a new thread by clicking this button, and then I would ask for infant mortality rates of Indian states and then hit submit. I can see that in the first instance itself, it is using the DuckDuckGo search tool a lot of times as we speak, querying things like infant mortality rates by Indian states 2023 data, then state-wise infant mortality rate in 2023, and then asking for statistics, and it is modifying the search query based on the response it receives, similar to a person doing this research will also probably do. And you can see it is also looking through Ministry of Statistics and program data of Government of India, essentially whatever is coming up in the DuckDuckGo search. So you can see that in the first instance, it did not give a state-wise data, so it just gave some kind of general data, and it suggested that a bar chart would be suitable for visualizing. And then the chart node is asking a question to the researcher, could you please provide specific high IMR rates for Indian states that you would like to visualize in the chart? And then the research node does more research on that specific request of the chart node, that is state-wise data. And you can see that this time it is asking for state-wise data in 2023 and all of the stuff, doing another round of research on NFHS data of 2022, doing a lot of querying, something probably a person in its place would also do. And this time from the NFHS database, it can find the infant mortality rates by Indian states. It also explains what IMR is and then lists out the states for which it has found data. And then it is saying the suggested chart is a bar chart to visualize this data. And the chart node has the correct information now, and then it is going ahead and generating the code. So if you see the subgraph steps for that, here you can see that it has first generated a block of code that shows the IMR data for those states, and then it is running it on the Python REPL tool that it has access to. Obviously, this time also it cannot find the module, but obviously if you're using some sort of API based Python REPL, this is not going to be an issue. But in our case, we'll stick to our experimental REPL, and it is again trying to modify the code a couple of times more. And finally, it says that the code for generating the bar chart is ready, but it is missing the matplotlib library and asks us to run the code in a Python environment with that library installed. So you can just go ahead and copy this code now, and I will run this in a Google Colab notebook. You can see that we have somewhat comprehensive analysis of the major Indian states based on their infant mortality rates. The IMR is quite high for UP, and from general knowledge, that seems correct. Now I'll go ahead and create a new thread, and I'll ask a similar question, maternal mortality rates of Indian states. And this time again, I will let it run the complete research. So you can see that even in the first instance, the researcher is running quite a few queries using the DuckDuckGo search. And then it moves to chart agent, which asks a few further details, which sends the flow back to the researcher, which sends more details to the chart agent, which starts writing the code to generate the charts. It fails for the missing libraries again, and it tries a couple of times before declaring that it has finished generating the code. This time we can see that this is the results for maternal mortality rates, and I can see that for Uttar Pradesh as well, the maternal mortality rates is very high. So I think if you had to do this research yourself, this would take a little bit more time than what the AI agent takes. That is going to be a long trail of Google searches. And I'll do a final one. I'll create a new thread again, and I'll research for GDP share of Indian states. I'll just copy this generated code and run this again. In the GDP share of Indian states, we can see that Maharashtra and Tamil Nadu are very high. From our qualitative understanding of state GDPs, it seems correct. The chart displays quantitatively as well how big or small each state's contribution is. The pie chart on the right compares the top 5 states in terms of their GDP contribution, which seems like a good idea to understand state-wise GDP distribution in the country. If you're familiar with India's economy, you know that Maharashtra contributes a significant share of country's GDP, which is illustrated in the pie chart as well. So if you want to do this kind of quick analysis, if you want to quickly understand, like, okay, let me understand the MMRs of Indian states or GDP share and things like that, then that can be done with much more ease, as we saw with AI agents. So let me know what you think about it. Obviously, you can do much more than what we have built here, but this should enable you to create complex agentic systems with relative ease. We have started from scratch, delving into all the nitty-gritty details of how you can customize it to create your own system. So you should develop a skill of choosing between when to use pre-built functions and when you want to go inside the nodes yourselves to customize the flow, which LLMs to choose for which use cases, how to refine your prompts to get the required outputs, and so on and so forth. That way you'll be building an agentic system that is not generic, rather wraps the business use case closely with fine-grained customizations, and more importantly, acts and executes in a predictable way. So with that, thank you for watching, and I'll see you in the next one.